where it sits. That plant in the corner of the room that nobody talks about anymore. The one that used to make the whole space feel alive. The one someone carefully picked out, brought home with real excitement, and placed in just the right spot where the light hits it perfectly in the morning. It is not alive anymore. Not really. The leaves hang like they have simply given up. Some have gone yellow. Others have gone brown at the edges, curling inward as if trying to protect something that is already lost. The soil looks fine. The pot looks fine. From the outside, nothing explains why this is happening. So what did most people do? They watered it more. They moved it closer to the window. They bought a bottle of liquid fertilizer from the garden section and followed the instructions exactly. They talked to it. They Googled the symptoms at midnight and tried 3 different things in the same week. And still, the plant kept dying. Here is the part that changes everything. That plant is probably not dead. Not yet. And the reason it is struggling has almost nothing to do with how much water it got or how much sun it received. The real problem is happening somewhere most people never think to look. Underground. In the dark. Where roots are slowly being destroyed by something invisible to the naked eye. Every single year, people throw away millions of plants that could have been saved. Not because the plants were too far gone, but because nobody told them the actual truth about what kills plants from the inside out. The gardening industry, worth over $47 billion in the United States alone, sells product after product designed to treat symptoms. Fancy fertilizers, specialty soil mixes, root stimulators in expensive little bottles with scientific-sounding names. None of them address the real killer. What if the fix was already sitting in the bathroom cabinet? What if it costs a single dollar? What if it works not by adding something complicated to the soil, but by giving the roots something so fundamental, so basic, that it sounds almost too simple to believe? Oxygen. That is the whole secret. Dying plants, in most cases, are not starving for nutrients. They are suffocating. And there is one liquid that delivers oxygen directly to the root zone, wipes out the microscopic pathogens destroying roots from within, and does it all without leaving behind a single harmful chemical. It breaks down into nothing but water and air. Hi viewers, here is a quick question before moving forward. Have you ever thrown away a plant thinking it was completely dead, only to wonder later if it could have been saved? Drop a yes or a no in the comments right now. That question matters more than it seems, because the answer for most people is yes. And that yes represents a plant that did not have to die. A plant that was abandoned not because it was beyond saving, but because the right information never arrived in time. That changes today. The solution at the center of this is hydrogen peroxide. Not some industrial-grade chemical. Not something that requires protective gear or a trip to a specialty store. Just the small brown bottle sitting in the first aid section of any pharmacy in the world, priced at around $1, labeled at 3% concentration, and completely overlooked by almost everyone who has ever struggled to keep a plant alive. What it does when it meets soil is nothing short of remarkable. It breaks apart. The molecular bond holding that extra oxygen atom to the water molecule releases, and suddenly there is a burst of pure oxygen gas moving directly into the root zone. Roots that have been gasping in compacted, waterlogged, oxygen-starved soil suddenly receive exactly what they needed. And the organisms that were killing those roots, the anaerobic fungi and pathogens that thrive precisely because there was no oxygen to stop them, they cannot survive what just happened. They collapse. They dissolve at the cellular level. Not because of a poison, not because of a harsh synthetic compound, because of oxygen, the most natural thing on Earth. And the plant, the one everyone gave up on, the one sitting in the corner looking like it has already said its final goodbye, begins something that looks almost impossible. It begins to come back. This is not a gardening myth. This is not an old wives' tale passed around in online forums. The science behind hydrogen peroxide and root recovery is documented, studied, and used quietly by commercial growers and hydroponic operations around the world. They know what works. They have always known. The question is why that knowledge never made it into the hands of the everyday person standing in a garden center, staring at a shelf full of expensive bottles, desperately trying to save something they love. Stay with this, because what comes next is the part that explains everything. Why plants really die. Why the most common response to a dying plant is actually the one thing that kills it faster. And exactly what to do with that brown bottle to bring something back that seemed completely lost. The answer has been there the whole time. Most people think they killed their plant. They replay the decisions in their head. Maybe they watered it too much. Maybe not enough. Maybe the window was wrong. Maybe the pot was too small, or the soil too dense, or the room too cold in winter. They take the blame entirely. They carry it like a small, quiet guilt that follows them every time they pass that empty spot where the plant used to be. But here is the truth that changes everything. In the vast majority of cases, the person did not kill the plant. Something else did. Something that was already in the soil before the plant ever started showing signs of struggle. Something that works slowly, silently, and completely out of sight. By the time the leaves start yellowing, by the time the stems go soft and the plant starts its visible decline, the real damage has already been happening for weeks, sometimes months. The killer has a name: root rot, caused not by carelessness, but by a specific set of conditions underground that most plant owners unknowingly create without ever realizing it. And the central condition, the one that starts the entire chain reaction, is the absence of oxygen in the soil. Think about what healthy soil actually looks like at the microscopic level. It is not just dirt. It is a living, breathing system full of tiny air pockets, channels, and spaces that allow oxygen to move through and reach the root tips where it is needed most. Roots do not just absorb water. They breathe. They require a constant supply of oxygen to carry out cellular respiration, to generate energy, to push new growth downward and outward. Without that oxygen, roots do not just slow down. They begin to die. Now think about what happens when soil becomes waterlogged. Every single air pocket fills with water. Every channel collapses. Every microscopic space that once carried oxygen to the root zone becomes blocked. The roots are suddenly surrounded by water on all sides, with no air left anywhere near them. And in that oxygen-starved environment, something shifts in the biological balance of the soil. Anaerobic organisms take over. These are microorganisms, primarily fungi and certain bacteria, that do not need oxygen to survive. In fact, they prefer environments where oxygen is absent. Species like Pythium and Phytophthora move into waterlogged soil the way a fire moves into dry timber. Quietly at first, then completely, they attach to root tissue, penetrate the outer layer, and begin breaking down the internal structure of the root from the inside. The roots turn soft. They go brown, then black. And here is the cruelest part of the whole story. The plant, sensing that it is not getting enough water through its damaged root system, sends out distress signals that look exactly like dehydration. Drooping leaves, wilting stems, dry-looking foliage that seems to be crying out for water. So the plant owner does the most natural thing in the world. They water it again. More than before, because clearly the plant is thirsty. And that extra water makes everything worse. More water means less oxygen. Less oxygen means more anaerobic activity. More anaerobic activity means more root damage. More root damage means more wilting, more distress signals, more watering. It is a cycle that tightens like a trap, and most people never realize they are caught inside it until the plant is completely gone. This is not a rare situation. This is the single most common cause of houseplant death in the world. And the gardening industry knows it. Walk into any garden center. Look at the shelves. There are bottles for root rot treatment ranging from $12 to $45. There are specialty drainage soils, perlite additives, copper-based fungicides, and mycorrhizal root stimulators, all of them positioned as the answer. Most of them treating only the surface of a problem that is fundamentally about one missing element: oxygen. Not a chemical compound, not a synthetic additive, just oxygen. Delivered directly to the root zone in a way that suffocates the pathogens, clears the damaged tissue, and gives the roots a fighting chance to recover. That is the entire solution. And understanding why hydrogen peroxide delivers that solution better than anything else on the market requires a brief look at something most people have never thought about: the chemistry of rainwater. There is a reason plants respond to natural rain differently than they respond to tap water from a watering can. Anyone who grows plants has noticed it. After a good rain, plants perk up in a way that feels almost immediate. The color gets richer. New growth seems to push forward faster. The whole plant looks more alive. For years, gardeners attributed this to the nitrogen that lightning fixes into rainfall or the slightly acidic pH of rainwater compared to tap water. Both of those things are true, but they are not the whole story. Fresh rainwater, formed in the upper atmosphere, carries dissolved oxygen in concentrations that tap water simply cannot match. As raindrops fall through the air, they absorb oxygen molecules directly. By the time rain reaches the soil, it is delivering not just hydration but aeration. It is watering and oxygenating at the same time. That dual action is what makes rainfall feel almost miraculous to a struggling plant. Hydrogen peroxide replicates that effect. When a diluted solution of hydrogen peroxide, H2O2, is poured into soil, the molecular structure begins breaking apart almost immediately upon contact with organic material. The bond holding the extra oxygen atom releases. That oxygen floods the immediate environment around the root zone. The soil, which was starved and stagnant, is suddenly rich with the one thing roots need most. But here is what makes this more than just an oxygen delivery system. The release of reactive oxygen during that breakdown process is lethal to anaerobic pathogens. Organisms like Pythium and Phytophthora, the same fungi destroying the roots from within, are built to survive in oxygen-free zones. Their entire biological structure is adapted to anaerobic conditions. When hydrogen peroxide breaks down and floods the soil with oxygen, it does not just remove their preferred environment. The reactive oxygen species produced during the chemical breakdown attack their cell membranes directly. They cannot adapt. They cannot relocate. They are eliminated at the cellular level. And the healthy root tissue? This is where the skepticism usually arrives. Because the natural question is obvious. If hydrogen peroxide is strong enough to destroy fungal pathogens, what is stopping it from damaging the plant's own roots? The answer lies entirely in concentration. At 3%, which is the standard pharmacy concentration and the only one that should ever be used for plants, hydrogen peroxide is potent enough to eliminate anaerobic organisms but gentle enough that healthy root cells, which have their own enzymatic defenses including an enzyme called catalase, can neutralize any excess before damage occurs. Catalase is produced naturally by plant cells. It is specifically designed to break down hydrogen peroxide into harmless water and oxygen. Healthy roots essentially protect themselves. Damaged root tissue already compromised by fungal attack lacks this defense. So the hydrogen peroxide targets exactly what needs to be eliminated and leaves the rest alone. That is not luck. That is biology working in perfect alignment. There is one more layer to this that experienced growers in hydroponic operations have quietly relied on for decades. When hydrogen peroxide breaks down in soil, the oxygen it releases does not just kill pathogens and feed roots. It also restructures the microbial balance of the soil environment. Beneficial aerobic microorganisms, The ones that support healthy root development and nutrient absorption thrive in oxygen-rich conditions. By flooding the root zone with oxygen, hydrogen peroxide does not sterilize the soil. It rebalances it. It removes the harmful anaerobic organisms and creates conditions where the beneficial ones can return. The soil does not just survive the treatment, it recovers from it. Now, here is how to actually do this. And this is the part where the difference between saving a plant and accidentally finishing it off comes down to a few specific details that most guides skip entirely. The first thing to establish before reaching for any bottle is whether the plant is actually still worth treating. There is a point of no return, and recognizing it matters. Press a fingertip gently into the stem near the base of the plant. If it feels firm, even slightly, there is likely still living tissue inside. If the entire stem collapses under the lightest pressure and the base has gone completely black and mushy all the way through with no firm core remaining, the root system may be too far compromised to recover. But if there is any firmness left anywhere in the plant, any green still visible under the surface of a scratched stem, treatment is worth attempting. Most plants that look completely dead still have something left to work with. The dilution ratio is everything. 1 teaspoon of 3% hydrogen peroxide mixed into 1 cup of water. That is the starting point for a gentle soil drench on a struggling plant. For larger pots, scale proportionally but never increase the concentration. The ratio stays the same regardless of pot size. More hydrogen peroxide does not mean faster results. It means burned roots, and a plant that was already fighting for its life now has an additional problem to survive. 3%. Always 3%. This cannot be overstated. Before applying anything, check the soil. If the surface is completely dry and cracked, water lightly with plain water first and allow it to absorb for about an hour. This matters because hydrogen peroxide solution poured onto bone-dry, hydrophobic soil tends to run along the surface and down the sides of the pot without ever reaching the root zone. Pre-moistening the soil creates a pathway for the solution to travel where it actually needs to go. Then, slowly and evenly pour the diluted solution around the base of the plant. Move in a circular pattern to cover the full root zone. Do not rush this. Allow each pour to absorb before adding more. The goal is to saturate the root zone completely, not to flood the surface. As the solution moves through the soil, there will be a faint fizzing sound and sometimes a slight bubbling visible at the soil surface. That is the oxygen releasing. That is the reaction working exactly as it should. Do not water the plant again for several days after treatment. This step is where most people make their critical error. They treat the plant and then continue their regular watering schedule. But the soil needs time to partially dry between treatments to allow the oxygen to circulate and to prevent the anaerobic conditions from immediately returning. The hydrogen peroxide treatment shifts the environment. Overwatering right after treatment reverses that shift almost immediately. Wait, check the soil by pressing a finger an inch below the surface. If it still feels damp, wait another day. If it feels mostly dry, it is time for the next treatment. Repeat the process once every 7 days for 3 to 4 weeks. The timing is not arbitrary. Fungal pathogens have reproductive cycles. A single treatment eliminates the active organisms present at that moment, but eggs and spores can remain dormant in the soil and begin a new cycle within days. Treating weekly for a full month breaks every generation before it can reestablish. After the first week, look at the plant, not at the roots which are underground and invisible. Look at the newest growth points, the very tips of stems, the center of leaf clusters. In plants that are responding, the first signs of recovery show up there. A faint flush of new color, a slight lift in leaves that had been hanging, a firmness returning to stems that had gone soft. It is subtle at first, then it is not. There is also a foliar component to this treatment that most people overlook entirely. While the soil drench addresses root rot from below, a light misting of the same diluted solution on the leaves handles something that often accompanies root problems but originates above the soil. Powdery mildew, a white dusty coating that appears on leaves during periods of poor air circulation and stress, is a fungal condition that weakens the plant's ability to photosynthesize. Aphid eggs and spider mite colonies often settle on the undersides of leaves during the same period of vulnerability. The hydrogen peroxide mist, applied lightly to both the tops and undersides of leaves in the early morning so it can dry before full sun exposure, addresses all of these simultaneously. One solution, one bottle, the entire plant covered. Different plants respond on slightly different timelines. A pothose or peace lily, both extremely common victims of root rot, typically shows visible signs of recovery within 10 to 14 days of the first treatment. A fiddle leaf fig, notoriously dramatic and slow to forgive, may take the full 3 to 4 week cycle before showing meaningful improvement. Succulents, which many people assume are immune to root rot because they are desert plants, are actually highly susceptible precisely because they are so often overwatered by owners who do not understand their natural drought cycle. For succulents, the dilution should be slightly weaker, half a teaspoon per cup rather than a full teaspoon, and treatments spaced 10 days apart rather than 7. Every plant has a pace. The treatment works with that pace, not against it. Now comes the part of this that even committed plant enthusiasts rarely know about. Because hydrogen peroxide does not just rescue dying plants. When used at the very beginning of a plant's life, before any problems have a chance to develop, it changes the outcome in ways that experienced growers have quietly relied on for years. Soaking seeds in a very dilute hydrogen peroxide solution before planting is a technique used in commercial agriculture to improve germination rates. The concentration for seed soaking is even lower than for soil drenching, roughly 1 teaspoon of 3% hydrogen peroxide mixed into a full pint of water. Seeds are soaked in this solution for no more than 30 minutes before being planted. The hydrogen peroxide softens the outer seed coat slightly, allowing moisture to penetrate faster. It sterilizes any surface pathogens on the seed itself before they ever have a chance to enter the soil. And it delivers a burst of oxygen to the embryonic tissue inside the seed at the precise moment it is preparing to germinate. Studies have shown germination improvement of up to 30% in seeds treated this way compared to untreated controls. 30%. From a 30-minute soak in a solution that costs almost nothing. For anyone propagating cuttings, hydrogen peroxide solves the single biggest problem in the process. When a stem cutting is placed in water to develop roots, bacterial growth in that water is almost inevitable. The water goes cloudy. It starts to smell. The base of the cutting rots before roots ever form. Adding a small amount of hydrogen peroxide to the propagation water, just a few drops per cup, keeps the water oxygenated and free of the bacterial growth that kills cuttings before they have a chance. Roots form cleaner, faster, and with a much higher success rate. And for anyone who has lost a plant to root rot and wants to reuse the same pot and soil, there is one more application that almost nobody thinks about. The old soil is not neutral after a plant dies from fungal root disease. The pathogens that cause the problem are still present in that soil, dormant, waiting for the next plant to arrive. Pouring a thorough hydrogen peroxide drench through empty infected soil and allowing it to dry completely before replanting eliminates those lingering pathogens and resets the soil environment. The pot does not need to be discarded. The soil does not need to be replaced. It needs oxygen, just like the plant did. Before closing this out, there are a few things to keep in the front of the mind every time that brown bottle comes out of the cabinet. Always use 3% concentration. Never use anything stronger on plants without significant further dilution. And if a mold problem in the home, on walls, floors, or structural surfaces exceeds roughly a 3 by 3 foot area, that is a situation for a professional assessment rather than a DIY approach. For everything else, that $1 bottle handles more than most people will ever realize until the day they actually try it. There is something quietly powerful about the moment a plant comes back. It does not announce itself loudly. It does not happen overnight. It happens in increments so small that most people almost miss them. A single leaf that lifts when all the others are still hanging. A stem that firms up after weeks of going soft. A color returning to tissue that had gone pale and tired. And then one morning, without any dramatic announcement, the plant that was supposed to be dead is just alive again. It was not a miracle. It was oxygen. It was $1. It was knowing what nobody told them until right now. Coming up next on this channel, something that experienced growers have been using in secret for years, an ordinary kitchen ingredient that when added to soil in a very specific way triggers a root growth response so accelerated that researchers studying it initially thought their measurements were wrong. The growth that appeared in the first week of testing was not supposed to be possible at that stage. What caused it, how to replicate it at home, and why it works on even the most stubborn slow-growing plants is coming in the next video. Do not miss it.